He Hello.
Hello?
Okay, we're on. Okay.
We're on.
Hi.
We're ready.
So our next talk is our friend for the third time here, Maciek, and he will talk about something that we all dream of, like zero code, right?
Yeah.
So enjoy the talk, and of course you can always visit our links for the bots and ask questions, and after the talk we are going to ask them together. Thank
hopefully. Okay, so welcome. Okay, so here are my slides. Okay, so thanks for coming, and thanks for having me for the third time in Belgrade. Wow, this is really spooky feeling when I hear my voice in the headphones. But nevertheless, so I'm Maciek Próchniak, and I'm from Warsaw, Poland, and I work for a small, kind of not so small software house called Tog, which is the best software house in Poland, or at least in Warsaw, or at least on the left bank of river. I'm dealing with various things from SGI integration to mostly stream processing and stuff like that. And today, I'll be talking about zero-code systems. Because I hope you enjoy the conference, don't you? The conference is great, the food is great, everything is great, but I have bad news for you. I mean, they want to get rid of us. Of you and me. Who? The business people. What do they want? They want to change the behavior of their systems without us, without the developers. We developers cost them a lot of money. We don't want to do estimates, we miss the deadlines, and they feel, come on, business rules are not so complex, I can change it by myself. Of course, you and me know that it's not possible. No business users will be able to handicraft such beautiful Scala code full of monads, business logic, futures, and so on and so forth. But let's look at two examples. The first one is this. Do you know what is it? It's Scratch. Basically, it's block programming in web browser. So my 8-year-old son uses it to have fun, right? And you can code pretty interesting stuff in it, including simple real-time games. So if my son can do this, then probably your business logic is also not much more complex than that. And your business users can do it. And another example is Excel. The Excel, the really power user environment for doing anything. Like you can have most complex statistical formulas. I think you can run a closure script as far as I remember in Excel. And remember that the Excel guys, the accountants, they essentially invented event sourcing and other cool stuff. So most of your business logic, and again, can be hand-coded by Excel by business users. So are we doomed? Is it really the last conference? Well, fortunately, hopefully not so, because in the list, somebody has to code the Excel. Somebody has to develop the Scratch. And this is us, the best developers in the Balkans, or in the Europe, whatever. And this is what my talk is about. It's a talk about our company's various attempts to let business users, or maybe external users outside of our developers, to change the behavior of the system, to change the business logic. I won't be talking about changing UI by non-programmers because I'm not qualified to do it. We'll be talking about changing of business logic. And to understand it further, you have to understand our business model. We're a software house, and our way of work is that we and other, of course, inferior vendors work for big enterprises like telcos, banks, and stuff like that, and they have different parts of our organization. There are business people, there are their internal IT departments, and ops. Of course, they should have DevOps, but they don't. Okay, let's stick to that. And there are different boundaries between all these parts. And the biggest and hardest to overcome boundary, the chasm, I would say, is here, because between us and our closest client, the IT team, because it's boundary between two different organizations, right? It takes money to cross it. So we want to enable these guys, also these and these, to change the behavior of the system without employing us. So this is the agenda. We start with something simple, with dealing with configuration, DSLs, stuff like that. Then we move on to more enterprisey stuff like Drools, BPMN, and so on. And then I'll tell you about our current project, that is Tog Newsnacker, that lets users do pretty interesting things. Okay, so let's start with something very simple. What could be more easy than letting users change behavior of a system via configuration? It's really easy. let's take one of my examples. That is the notification system. There are some events that pass to the notification system. Oh, I don't see my arrows on the screen. Not too bad. And we have some configuration database, and then we decide should we react by sending email, SMS, what are the templates, what are the redelivery configurations, and so on. So it sounds like easy peasy. The system is really flexible. We developers don't want to deal with configuration. But then I had this discussion between our team and our client. So my friend said, John or Patrick, don't make changes to configuration in production. We have to review it on the test. We have to test them, and only then you are allowed to make the change. And he says, but you made the system so configurable so that we can do the changes without asking you to review them. Right? Why do you have to review it? Well, because it's complex and you can make mistakes and make systems stop working. Right? So for me, the first very simple lesson is that it's very easy to make system too difficult to be changed by user, even with configuration. Right? Let's move to some kind of more of a success story. Next case would be really, on the screen I don't see any arrows. There should be arrows in light gray, but the screen just erases it. So you have to believe me, these are the arrows between the boxes. Too bad. So our next client was a logistic company. They have a lot of integrations between systems with their warehouses, with truck companies, with different vendors who they make deals with. And the clients come and go, the truck drivers have accidents or whatever and drop out of business. So the integration changed pretty quickly. And again, they don't want the vendor of their integration platform, that is us, to change the behavior. So our first attempt was to learn them to use Apache Camel DSL. We learned the guys working at the logistics firm to do simple integration by just writing some simple XML and uploading them to the server. And it worked. They landed, and they were happy. But what was left was some more difficult integrations. And sooner or later, we learned that they used some tool to document the stuff, and it was called Autova MapForce. It's not so modern system, but it worked. They used it. And what's more, we discovered that it could allow some, I would say, pretty shitty Java code, but it could be done, and we can integrate it in our platform. So we let the users use the tool they used before, but this time to make runtime changes. And very soon, they learned to do pretty impressive integrations with that. I hope you can spot that here it is a bug in the filter, right? But they are using it, and they are pretty happy with it. So for me, again, the next lessons about letting user change stuff is it's very important to know which tools do they use, how do they work, and let them use them to change the behavior of the system, and to make the deployment easy, because only then will they use it. Right? So these are the very simple patterns. Now let's move on a little further to the DSLs. I'm sure most of you use DSLs here and there, internal, external, in various forms. But how can we let users use our DSLs to change the behavior of the system? This time we're getting again back to the see this arrow to the telco company, and this time we're designing systems that handle various alarms, network alarms from different transmitter stations, from devices from Ericsson, Nokia, Huawei, from transmitter stations. For example, when there's thunderstorm or some maintenance, they send quite a lot of alarms communications, and our system had to react kind of real time. For example, to let the operator see it or not, to clear it, to add some certain notification, and so on. So again, the logic of the system changed pretty quickly, because new devices come and go. For example, there are temporary problems like network grid problems that cause the devices to stop working, or there are men at work, for example. We know that this week these base transmitter stations will send strange alarms because there are some maintenance workers working on that, and we don't want to care about it. So what we noticed is that there were different kind of users using our system. One of were kind of line users that just sit in front of large screen and click OK, turn this alarm off or on. There were the coordinators that knew what really happened, and there were the IT guys that knew how to integrate new stuff, for example. Okay, so for normal users, they needed some simple filters to perform simple actions. And what we gave them was this. You see, this is simple jQuery widget that allows you to write some custom statements. And you don't have to write anything, you can just click it up. Okay, we used some different stuff, but similar, and the users used it. And for more kind of half-power users, we gave them the possibility to use Drools. We'll talk about it a little bit later, to handle some global filters, correlation between events, and some temporal, I would say, logic. And for real power users who wanted to add new devices to connect them, well, they can always use Groovy. It turned out that they were technical enough, they had some programming background, that they could write simple Groovy scripts, deploy them, and again, it worked pretty well for them. Of course, there were some problems, like they didn't have proper IDE. Sorry, some Groovy DSL had to be prepared for them. And again, there were some problems in deployment and testing. If they wrote some Groovy code and the system exploded, whose fault was that? Ours or us? But nevertheless, it worked pretty well. And the lessons that I learned from that case was that not all users are created equal, and you have to think about different ways to satisfy their needs. Some of them are more powerful and some not. Some of them need more help and guidance, and some not. Okay, so these are all kind of, I would say, handcraft ways of dealing with those changes. Now let's move to some more enterprisey stuff. How many of you know Drools? Okay, not so much. So, this is a rules management system from JBoss. And it has certain appeal for business users because what they see is business. That's us. Rules. Rules, yeah. Management. Yeah, management. We want management. And system. Okay, so this is something for the IT folks to deal with. So they think, okay, we'll really use it to manage our rules. And what they get instead? Something like this. Doesn't look so sexy as the former slide, unfortunately. But in fact, it's not so bad. This is kind of rules that got a little bit out of control. We've been using Drools in various situations for our telco clients for, I would say, more than 8 years. Some were pretty successful, some maybe not. The successful stories, again, no arrows, were the alarm detection systems that I told you about. Again, we let the kind of more power users, more sophisticated ones, to generate rules that can react on certain events from the system that take into account what is the current situation, current state of knowledge, the inventory, what devices do we know about, what are the current alarms, what are some external configurations, and make some actions. And another example is our custom automatic IVR system. When you call the call center, some random melody is playing, and we invoke the rules. We are seeing who you are you a really good paying customer, then you will be allowed to talk to a real human. And if not, well, we always have some stupid chatbots. Okay? So again, this is kind of simple case where rules work. For those of you, I mean, most of you who didn't use Drools, this is how such a rule look like. Okay, we have the when section, just like in BDD testing, right? Given when then, but then we have only when and then as a rule, and when certain conditions on our knowledge about the world that we have are satisfied, we invoke some code. In fact, this is just normal Java code. But these conditions are written using some pretty simple DSL. So it works pretty easily. And the good thing, when you think about making external users define the rules, is that the Drools work model is essentially stateless. You take some input data, your knowledge of the world, you throw it into your rule system when you have kind of more or less static set of rules, and you get the output. You know what this is? This is a pure function without side effects. You just have some output data, and that means it's really easy to reason about, quite easy to be tested. So it's good for end users to change it. But the biggest killer feature of Drools is the ability to read the rules from Excel sheets. This is something that really makes Drools usable, because business users can express those conditions in some Excel sheets which they understand, and they are transformed by some generic method to the rules, right? So this is something that they know how to work with. Okay, there are even some efforts to make a standard out of it. It's called BPMN. I don't know at what kind of stage it is. We've been using pure Drools, and it was more than enough. Of course, Drools have also quite a lot of downsides, because when you see such rule, it looks easy peasy, right? But underneath, there are pretty complex algorithms employed to make this whole thing scalable. It's called RET algorithm. You have to think, how do the rules work? Is it forward propagation or backward propagation? And if you try to do something like Hibernate to load more data in the runtime, then you can easily get to some performance problems. And this is a problem because it's kind of an abstraction leak, and for our clients, more often than not, they treat the rules as just a bunch of ifs, and underneath it's some more complex machinery. And the rules, when they get out of control, you get something like this. This is not something I invented. I was given this picture by my friends who worked with my Drools code, and they said, yeah, this is us, when we are trying to debug it. Okay, so for me, lessons learned: Drools and rule business systems work when the rules are stateless and simple. When you can use XLS, you can be sure that you will get acceptance and engagement from users. And again, as always, if your abstractions leaks, then your users won't like it. Okay. Which brings us to even more enterprisey stuff, and that is BPMN. The holy grail of zero-code systems, the stuff that many vendors try to sell as a panacea for the needs of the developers. Okay, so what's the idea? How many of you have heard or used of BPMN systems? Yeah, some of them. So the idea is that here comes business users or analysts or even some developers. They design nice diagram in some more or less graphical user tool that depicts their business process, right? There are some interactions with external services, some interactions with humans, some rules, and some logical gates like OR or parallel gateways and so on. And what happens next? We take this nicely crafted diagram, we transform it into not so nicely looking XML, and we do what? We deploy it. And we're happy. And where the business users want to change, or the analysts want to change the process, they can do it, redeploy it. You don't need any pricey developers, isn't it so? Yeah, so we tried to use this BPMN stuff on one of our larger projects, that is handling of mobile number portability processes. If you know the telco operators, you can, I think also in all the countries, you can move your phone number from one operator to another, for example, from Vodafone to Orange, and you still have the number. So it's a pretty complex process involving not only new customer, not only most of the systems of a telco operator, but also communication with the other operator who has to, agree to give the number away. So it's pretty large, complex, and sometimes lengthy process. Sometimes it can take days or even weeks. Right, so it seems like a really good place for BPMN or stuff like that. So we started with BPMN predecessor, BPL. It was really horrible. Fortunately, it's extinct now, I believe. Then we moved to latest and greatest BPMN engine, that's Activity. It's still being worked upon, although there are some frictions in the community. Yeah, and now we are finalizing process of ditching Activity and moving back to pure Java and Scala. So it was, I would say, that's kind of a bit of a failure, right? Isn't it? Why did that happen? Why did BPMN not work? Okay, so here there should be frames, whatever. So the problem was that we, developers, were used to a bit different way of working. You know what? We want to use Git, we want to write unit tests, to have continuous integration or even deployment. We want to use either favorite IDE, that is IntelliJ, of course. We want to be able to easily refactor code to extract function, abstract away certain things. And all those BPMN tools, they're more focused on visualization, about storing processes in some external repository, about using web designs, not IDE. But you may very well ask, but it was not you who should change these processes. Your analysts or your business users should change them. Well, they should, but they never did. They never did any. They never took any attempt to change the processes. And why? Because the changes were pretty rare. And they were different than we expected. We were expecting that, okay, there will be some changes in the logic of the process, in the diagram, they'll change it, and the rest of the system will remain untouched, and everything will be fine. But what happened was that most of the changes that happened involved integration with our systems, right? So again, the integration part was where the code has to be written, where we developers had to be employed anyway. So it was no use for them to change anything, because they anyway had to ask us for help. But there are also bigger problems with that, because BPMN processes are kind of inherently stateless. One of their key goals is to be able to use timers, to be able to use some exceptions handlers to correlate events from different systems. And handling such events is pretty hard. Sooner or later, you have to learn what Saga is, you have to learn how to do compensation handling and so on. And our analysts and business users don't want to think too much about that. And even more difficult in all those BPMN processes is handling versioning. This is really hard task that is not so easily done by non-technical user, right? If you have one version of a process deployed, it kind of works, and then you want to deploy another version. What do you do with running processes? Do you want to migrate them, but then you have to think, is this change compatible or not? Will it be possible to migrate in some different way than updates or on database? And if you let the old process go, and in the old logic, will the old integrations still work and so on? So this is the stuff that our customer didn't want to think about. And this is, again, a telling conversation I had with my customer. So he told me, Maciek, we'd be able to code it ourselves, right? We know how to code. But our manager will ask, who will be responsible for that functionality? Who will maintain it? Who will be on the call when something happens? We don't want you, our customer, to be responsible for that. So that's why we hire you, the Talk software house, to take care of it ourselves. And this is, if you think about it, this is in fact the way it should work. Because when we develop some functionality, there are different places when the tests happen and where bugs may be detected. In our development environment, on test environment in the customer, and on some user acceptance tests. And if we let our analysts or our customer to change the behavior of the system, they'll detect errors only here, or sometimes they'll just go to the production, right? So it's not so safe to do it. And if you think about it further, it highly depends if you can use safely BPMN or other stuff like that. It highly depends on the nature of your system. About the correlation between how critical it is, how is it really dangerous to make some mistake, and how fast the changes go. If you're here, not critical system that doesn't change too often, nobody cares, right? If you're here, it's really vital system for you, and it changes pretty quickly. Then maybe you're kind of a startup or something like that. And here, our customers are usually somewhere here, right? Either it's critical system that they don't change too often, and then maybe it's better to let the developers handle it. And on the other hand, it can be fast-changing systems that's not that important. Probably some SMSs, stuff that can be handled and repaired if something is broken. And then this is the sweet spot where stuff like BPMN or other such tools can be employed. Right, so I still believe that BPMN has its usages, has its valid usages, but more like workflow-like areas where the processes are kind of simpler with less integration, more human tasks, and it's more difficult to make some errors. But nevertheless, you'll always need developers, and even the kind of more honest or sincere vendors of BPMN system admit that. Right, this is a quote for Camunda, which is doing one of the, I think, more interesting BPMN implementations currently. So if you want to use something like that, go to them. They are really professional stuff. But they admit, yeah, you don't get rid of developers so easy. Okay, so for me, the lessons learned from my BPMN adventure is that it's not the coding that's the problem. It's running on production, maintenance, handling versioning, exceptions, that is the problem for our customers. And that if you have a lot of integrations and stateful processes, it's really hard for the business users or analysts to change the behavior. Okay, time for a quick recap about lessons that we've learned after a few years of doing such stuff. First is that, again, of course, we have to know our client, how competent, how technical they are. Maybe they've learned SQL, maybe they've learned to code Java some time ago, and now they only were promoted to analysts or management. And how fast does the process change? Is it safe to change it? Is it really worthy to let the user change the process? Or the changes are, I don't know, once in half a year, when it's maybe not worth the fuss. Right, again, and it's not coding, but maintenance, SLA, and taking responsibility for the code is hard. And sometimes business users could change the behavior, but they don't want. They don't want to take the responsibility for the changes. Only when some parts are safer, they are not afraid to touch it and to deploy it by themselves without the kind of assistance of developers. Right, and it's also important to know where to stop. Some things are better coded. Not all the things could be designed in some DSLs or in some graphical tool. And we should make it explicit and again, as usual for Pareto principle, to solve most of the easy use cases and let the real developers do the rest. Right? So with all these lessons learned, we started to design my current project that I'm currently working on, and it's called Token Snacker. So what does it do? Well, the domain this time is real-time stream processing. If you've heard about Spark streaming or stuff like that, then this is the way. So again, we're in telco. We have a lot of data, probably many thousand per second, coming from some billing data, from clickstream, and from some signal data. Each time when you use your phone, some data is sent to the operator and he can react upon that. And why do we process all those data? Well, of course, to send you stupid advertisement messages. This is kind of a sad truth, but this is what we are aiming at. But also some more noble goal is that fraud detection. I haven't dreamt of so many sophisticated ways that people are able to make frauds for telcos. It's really interesting. So there are lot of processes that the business people, the revenue assurance guys can come up with, and they want to make it easy for them to react on different streams of data. Such like you make a call, we check in real time, in kind of few seconds, are you close to your credit limit? If not, if yes, if you are prepaid, maybe we can send you an SMS, okay, buy this package of data. If not, maybe we can check where are you located, where is your phone, maybe you're on your point of sales. And then we can send you an SMS like saying, okay, come to us, you'll get coffee. I wouldn't do it, but people do it. Okay. So for that we are using Apache Flink. Have you heard of Apache Flink? Probably not. If somebody has heard, it's very good. It's kind of, I would say, alternative for Apache Spark, right? So it's stream processing platform, can handle millions of events per second and so on and so forth. And it has really nice, powerful DSL that lets you design your processes quite easily. If you are a developer and if you know Scala. In Java it looks a bit more complex. So for us it's readable, but for our revenue assurance guys and marketing guys, not so really. So what to do? At first we tried to employ configuration files and say, okay, this is the configuration, you can change some behavior of the system. But our client said, no, okay, but it's not what I want. So then we thought, okay, maybe you can write pieces of the process, some Scala expressions. We didn't tell them, of course, it's Scala. And again, upload it, and it will change the behavior of the system. And he says, no, yeah, it's a bit better. But still, you know, your competition has such nice graphical user interfaces. Okay, okay. So we'll build you a graphical user interface where you can design your processes. Okay. And what's more, you'll pay only half of the price, and we will make it open source. Okay, do it. So we've done it. It's called Nusnacker. If you like the logo, it's open source project on GitHub. If you like logo, I have nice stickers with it. And it's up and running. And when we tried to design it, we had some few principles in mind. So first was that the expressions that, for example, do the filtering or some mapping of conditionals had to be accessible for semi-technical people, not really business people, but people who can kind of know SQL, right? Analysts. Again, the second assumption was we wanted to really make testing and experimentations and deployment easy for the people, and to assume that there are certain parts of the code that has to be written by us, by real developers. The integration, the definition of the model of data that you act upon. So it works more or less like this. First we code the integration, the model. We have some configuration, for example, where are external systems located, and we let the users create processes. They are serialized. It's JSON, and the model, the integration code, is deployed to Flink cluster. It's kind of complex business, but the general idea is that. So where do the JSON is coming from? Well, it's coming from UI, right? Yeah, this is the stuff that we designed, so the user can design a process that when event comes from here, filter on some condition, and reach it, invoke some external system to get additional data, and so on and so forth. And he can have some toolbox, drag and drop stuff, connect arrows and boxes. And some of the stuff is actually pretty generic, like filters and so on, but some are integrations coded by us, right? So these are not generic, they are just put into the jar, and some, in some automatic way, they are extracted and given to the user in form of toolbox. And again, when user wants to, for example, to define some filter, how to filter out some events, he can write some expressions which are even validated on the fly, so it's easy to them to spot errors. And do you know what is it? It turns out it's Spring expression language. We thought first about SQL, but then we decided to go with Spring expression language, and it turns out that it's quite accessible for business analysts to use. It's quite fast. Essentially, it can perform pretty well. And what's more important, it's able to analyze the expression and do some basic code completion, right? So when user enters some expression, we can tell them what properties this certain model has. So it's quite convenient for them to work with. Of course, these were some filter expressions invoking external systems, but once you get accustomed to creating such diagrams, you have to think, okay, I would like to have variables, I have if them else, maybe I would need some loops, maybe I would need some sub-processes, some subroutines, how do I handle exceptions, do I have go to, and so on and so forth. And quickly it can become, really complicated. So we don't do this. We stop at certain moment, we only allow users to do simple stuff, because we figured out that as we strive to be as complete as possible, the complexity of our solutions, rise exponentially. So we want to stop somewhere in here. So the users of our tool can do simple stuff, but if they want to do something more complex, they have to code it in Scala or Java, deploy it as kind of a jar file, and then the end users, the analyst, can use it by some opaque black box tools that they can only configure a bit, right? So we hide away this from the users. But designing is not everything, and testing is kind of equally important. So here we have our stream of data, and we replicate it to the production and to the test environment to make users feel safe, to be able to do testing on some user acceptance test environment. Fortunately, our system is not so critical. We only send spam text messages, so if something bad happens, it's not that bad, because we have some circuit breakers that don't allow users to send SMSs to all customers of our telco. But unfortunately, our client quickly got quite reckless and said quite a few times, okay, we'll do it our way. First, we'll deploy it on production, see what happens, and then maybe, okay, we'll deploy it on test. That was not such a good idea. So we wanted to make testing easier for them, so that they can, so that they don't do this. So in our system, it's quite easy to generate meaningful test cases, because if you have a large and complex data model, it's not convenient for the users to write test cases themselves. So what do? We have a button to generate test cases based on real data that flows through the system. Essentially, we take, 10 or 100 of last events that flow through system. We dump it to the file, the user can see it, adjust a bit some parameters, and test it from file. And then he can see the test results. Okay, so my test involved 5 events from the start. Here there were some filters, and here only 1 event persisted. And he can debug inside to see why this filter filtered out 2 events and so on. And when you deploy it on production, of course, they have some automatically designed custom metrics so that they know what is going on. Okay, if you ask if it works in production, yes, it is. For more than 1 year in one of the largest Polish telcos. And as I've said, we're doing real-time marketing and fraud detection. And it works pretty well. This is the biggest process that was designed by our customers, so I don't know what it's doing. It's too complex for me, and we handle quite large traffic. In peak, it's like more than 120,000 requests per second, and all of this is handled by processes designed with graphical user interface and with a lot of Spring expression language expressions. So for me, it's quite impressive. But of course, we're not done. We're just started our open source project, so there's still a lot of features missing and documentation. But to try it out, it's here. It's Talk-No-Snacker on GitHub, and if you feel interested, just feel free to try it out. We have some good starts. Okay. Thank you. Are there any questions, Igor?
Yeah, so here they are. So we have, I mean, a few more minutes for the questions. One question is, how often do you need to change or to add a new functionality that comes from the business layers? You know, like how, I mean, how modular your system is. You know, how do you feel that? How often that happens?
Yeah, this is a very good question, and it depends on the various use cases that I thought about. Right? In some systems, it's like one in a few days. For example, these alarm detection systems, this changed quite a lot because each day they did do some maintenance work on their devices. On the, for example, on these logistics systems, probably once in a month or something like that. But I don't know because they do it by themselves. And here it's also not so. I mean, at the beginning of creation of the process, it's in a flux. Like they're doing quite a lot of experimentations. But after it stabilizes, and they want to do it themselves to make the experiments. But after this stabilizes, then yeah, not so often. I mean, if, for example, if marketing campaign is working, they probably don't want to change it that much. So it depends, right?
Yeah, sure. Thanks. And one more question is, I'm just curious, like, do you have some certain preparation for business guys, you know, to learn about the system,
Yeah, again, it depends on the system. Sometimes we allow almost the business guys to touch it, but in many cases there's one step between the real business people, for example, the marketing guys and us, and that is kind of analysts, like not really developers, not really business people, people who more or less know how to use Excel and know how to use SQL, right? So they are not so technical, but they usually tend to be quite intelligent and capable of grasping all the aspects. Some time ago, I was really surprised how much stuff they can do with our systems without asking, right? Without business users, real marketing guys and so on, it would be a bit more difficult. They usually want to change some simple stuff, like, for example, change the email, change the threshold of the alarm, and so on.
Okay. Thank you. If you have any more questions, you can ask him after.
Yeah. And if you want stickers, I also have them.
Oh, yeah.
Thank you very much.
We all have stickers.
Yeah.
Thank you.